I hope you are quite well and your study is going very smoothly. Uh, Today we are going to start the carboxylic acid. This is lecture number 0 I have given because this is the physical properties and the structural properties I am going to describe here. Okay, so let's understand here. Once you understand, please like, share and subscribe the channels. Students, we talk about the carboxylic acid. It is the carboxylic acid. See, carboxylic acid is what? C double bond OOH group, right? So this is the carboxylic acid group. Now see, when this compound dissolve in the water, that this compound will ionize. What happen? And ionize and give the H plus ions. Since it give the H plus ions, hence we can say that it is a acidic. Carboxylic acid is acidic compounds. Okay. Now we talk about the derivatives of carboxylic acid. What derivatives? Derivatives of carboxylic acid. What is the derivative of carboxylic acid, students? The one is that R C double bond OX, which is called acyl halides. Okay. Second, I write here R C double bond O, O C double bond O R. This is the anhydride. Anhydride. Third is here R C double bond O NH2. This is the amide group. And here is that ester R C double bond O O R. This is the ester group. And the next is the RCN nitride, right? So these the compounds are the derivatives of carboxylic acids. Okay. Now see here, student, I write some important aliphatic compounds, which is very helpful to solve the conversion or simply mechanism is given that in that case you can easily solve that. See, here is the important aliphatic acids. What the important aliphatic acid is that? First, I write here CH3, CH, CH3 and COH. That is called isobutyric acid. Okay, this is the isobutyric acid. Second, CH2 double bond CH, COH. Still, if you have a 3 carbon and 1 double bond, 3 carbon with the 1 double bond, that is called acrylic acid. Okay, and one more here, that the 4 carbon and the 1 double bond attached on the second position is called croto. That is called, if you have 4 carbons. Okay, so here is the 4 carbon and second double bond is there, 4 carbon along with the including with the functional group here. That is the crotonic acid. If you have a CHO group, that is crotonaldehyde, right? So whatever group we will attach here, that is the croto. That is 1, 2, second position double bond, including the functional group I am telling. Now we talk about CH3, C double bond O, CON. This is called what? It is called pyruvic acid. What we can say? It is called pyruvic acid. So this is the pyruvic acid. Now we talk about the important aromatic acid. Aromatic acid. And this is the important aromatic acid is what? Important aromatic acid is one is benzoic acid. Already we know this is the very popular name, benzoic acid, simplest aromatic acid. And the second is that phthalic acid. I write here COOH and COH. This is phthalic acid. And third is I write here salicylic acid. We have done in the alcohol also. OH and COH. That is called salicylic acid. Okay, and fourth is that here is OPT, orthometapara toluic acid, right? This is the OM or P toluic acid. Okay, and one is second is COOH NH2 anthracic acid, or this is the 2-amino benzoic acid, right? So 4th and 5th compound we have done that. Now we talk about students. I tell you that diacid. If you have a diacid, how to diacid means carboxylic acid. So if you have a dicarboxylic acid, then what? See how to write the tricks, dicarboxylic acid, how to remember it. Simply you tell me the ohms gap and C's trans. Okay. See here, ohms 2, 3, 4, 5, 6, 7. Can I write here? It means what? The C, COOH, COOH. That is called the two acid is there and total 2 carbon is there. O means oxalic acid. Okay. Similarly, M means malonic acid, and malonic acid contains 3 carbon. One is COOH, second is the CH2 and COH. This is the malonic acid. What? Malonic acid. Okay. And here is that strength, 4 carbon. One is CH2, COOH. Here is a CH2, COOH. This is the called what? Salicylic acid. Succinic acid, sorry. Here is succinic acid. Okay. So see 4 carbon and I have written 1, 2, 3, 4. This is the succinic acid. Okay. Now we talk about what next is butyric acid. C 5 carbon is there. I have written here 5 carbon and that is the CH2, COOH, CH2, 1, 2, 3, 4 and 5. This is the called butyric acid. Okay. And C6, 6 carbon here is what? Strength? Well, 6 carbon is a adipic acid. What? Adipic acid. And what would be the adipic acid here? CH2, COOH. It is the CH2, 1, 2, 3, 4, 5 and COH. So 1, 2, 3, 4, 5, 6. This is the called adipic acid. Okay. And next is the 7 carbon. C7. See the tricks I have given here. 1, 2, 3, 4 starts and go to the 7. 7 carbon is the called pimelic acid. Pimelic acid. And pimelic acid, how to write exactly? CH2, 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 COOH, 4 carbon, 5 carbon, 6 carbon, and 7 carbon. That is the pimelic acid. Okay. Still, cis trans means what? Cis trans means we write the cis malic acid. Okay. Cis malic acid is what? And next is the transfumaric acid. Cis malic acid, how to write? H, C, here is COH, double bond, C, H, COH. This is called malic acid. And fumaric acid is what? H, C, COH, double bond, C, COOH, and CH. Here is the what? Called trans. It is a trans, na? So it is a trans and C strength. Here is a C. I write here properly. Okay. So what we'll write here? Trans C. C, COOH, and here is a C, COOH, and H. This is the trans. COH is trans, and that is the fumaric acid. These are the name are very important strengths, and that is used in the common name. And we have done some common name of aliphatic, aromatic, and carboxylic common names. We have done that. Now we go to the state. That state means we are going to understand physical properties, melting point, boiling point, like that. See, strengths 1 carbon to 9 carbon, C1 to C9 acid is what? Colorless liquid. Okay, with unpleasant odor. Okay, at room temperature, right? Now we talk about more than 9 carbon. More than 9 carbon is what? Still more than 9 carbon is a solid. Okay, and odorless. Odorless because what happened? Because of their low volatility. Low volatility. Okay, that is the regions. That is the odorless. Okay. Now we talk about in talk about the dimer state of the acid, because acid formed dimers, but in aprotic. In aprotic solvent, aprotic means CH3, COCH3 means which are not able to form the hydrogen bonds. That is the polar, but will not form the hydrogen bonds. CHCl3. This is the aprotic solvent which will not form the hydrogen bonds. And non-polar dipole moment is 0, and polar solvents like we have CCl4, okay, like that compounds, or CO2 or CH2 like this, or in vapor phase. In vapor phase, your acid will form the dimer. What? Acid. What the dimer? Dimer means strength C. 2 moles of acetic acid. When this solvent you have taken, non-polar or aprotic solvent. So what happened? This compounds CH3, C double bond O, C, O double bond O, CH3, and H is there, right? Here is the H, and here is the H. So it will form the hydrogen bonds, and it form the dimer. 2 moles you have taken, and that the 1 molecules will form. Okay. Now we talk about the boiling point strength. Of course, it has a higher boiling point. Acid has higher boiling point because of intramolecular hydrogen bonding. So of course it has a high boiling point. Boiling point high. Why high boiling point? Because of intramolecular hydrogen bonding. Okay. Now we talk about melting point. There is no trend, any specific trend in the melting point. The melting point is a very simple way, that the odd number of melting or carbon if you have, or even number. If you have even number carbon, you can see here CH3 1, 2, 3. So 1, 2, here is 2 carbon, 3 carbon, and 4, and both the carbon are opposite. So opposite means force of attraction will be increased. Since force of attraction will be increased, so that fit into the crystal lattice. Okay. Now we talk about odd number, CH3 2, 3, 4, 5. So there will be the huge repulsion here. So that not fit into the crystal. That is the basic regions for the melting point, high melting point, even number carbons. Okay. Now we talk about the solubility. You can see here. Now we talk about solubility. What happened with the solubility? See, C1 to C4 up to 4 carbons atoms are what happened? Miscible in water. Okay, due to hydrogen bonds. Correct? Due to hydrogen bonds, C1 to C4 are miscible in water due to hydrogen bonds. Now we talk about the benzoic acid. What? Benzoic acid is the simplest aromatic acid. This is the simplest aromatic acid. This is the benzoic acid, is simplest aromatic acid. Aromatic carboxylic acid, aromatic carboxylic acid. Okay, the simplest aromatic carboxylic acid is almost what happened? Soluble in cold water. Okay. Now carboxylic acid, even though carboxylic acid, even in the very less polar, even in very less polar, okay, very less polar organic we talk about organic solvent, very less polar of organic solvent, like what? Like if you have benzene, okay, like benzene or ether or alcohol or chloroform, benzoic carboxylic acid is also partially or slightly soluble in these substances. Okay, so student, this is the physical properties and structure. I hope you have done that, you understood it. Thank you. Have a nice day and take care of yourself, students.